Okay, we've seen that in the equation we've been looking at, we've identified our m function and our n function. Our m function is the derivative of some function f with respect to t, so we know the derivative of f with respect to t is this, and that the derivative of f with respect to y is this. So the big question is, what is our function f? Well, if derivative of f with respect to t is this, then one thing f is equal to, and f is a function of t and y, is an integral of square root of y minus e to the t cosine y plus t with respect to t. Now, we can integrate that. Okay, treating y as a constant, this is going to be the square root of y times t, and then the derivative of, well, treating y as a constant, cosine y is constant, and derivative integral of e to the t is e to the t, so we're just going to get minus e to the t cosine y, and then we're going to get t squared over 2 plus an integration constant. Now, the trick with the integration constant is y is constant with respect to this integration, so any function of y, and let's call this any function g of y is constant with respect to integration with respect to t. So putting a g of y in here does not change the fact that the derivative of this function with respect to t is our m of t function, our m function, which is f sub t. Okay? And also, of course, f of ty equals the integral of this function, which is t over 2 square root of y plus e to the t sine y, integrating with respect to y. Now, when we integrate with respect to y, we're going to find that any function of t is fair game as a constant. So rather than integration constant, we're going to get some function of t, which we'll probably call h of t. Integrating what we have here, treating t as a constant and y as our variable of integration, is t square root of y minus, doggone it, e to the t cosine y. And then our integration constant is going to be some function which we'll call h of t. Once more, the derivative of this with respect to t, g of y doesn't have any t in it, so it goes away, and we have the derivative of this, which is going to equal this. Here we have a function h of t, but when we take the derivative of this with respect to y, that h of t is going to go away. It's going to be constant with respect to y, so the derivative of what's left is going to equal our n function. Now we have to reconcile these two functions. We have, in this version of the function, we have a t squared over 2 that isn't here in this function, except that it is because we've allowed for any function h of t. So h of t is going to be our t squared over 2. Now, do we have anything in this function that we don't have in this function? Well, we've got square root of y times t, or t times square root of y in either order, and we got an e to the t cosine y, which is negative. So we don't really need a g of y, except that we're going to let g of y just equal a constant c. We don't need any more functions of y. And we can write this then as f of ty equals t square root of y, let's use that order, minus e to the t cosine y, plus t squared over 2, which covers our t squared over 2 here, and it's an h of t, plus g of y, which we're going to call c. And this is the function whose t derivative is this, and whose y derivative is this, and this is the most general function that satisfies this. Now we'll see how to use this to write out some sort of an implicit or hopefully explicit solution.